Humanity has been working towards living on Mars for decades. However, now it's not just a dream, but a reality unfolding, thanks to 3D printing and space architecture. This is Manufacturing MARSHA. In 2015, NASA announced the 3D Printing Habitat Challenge, which called upon the world's brightest minds to craft a Martian home. Fast forward 4 years, and let me introduce you to MARSHA, the architectural feat developed by AI Space Factory that claimed victory and a well-deserved $500,000 for its groundbreaking design. Why exactly was it so successful? Well, let's find out. While it may not resemble sci-fi domes, MARSHA's egg-like shape isn't just for looks. It's engineered to minimize mechanical stresses, use materials efficiently, optimize printability, and boost productivity and satisfaction. Take structural stresses, for example. Unlike sharp-edged objects, vertically oriented cylindrical shapes efficiently and evenly distribute pressure. Sharp edges and corners create stress concentrations that can lead to failure under pressure, making vertically oriented cylinders perfect for the job. On top of this, vertical cylinders use space efficiently, requiring less material for the same usable floor space. Less material, more functionality. It's a win-win. Speaking of wins, vertically oriented cylinders are way easier to print than domes. This is because vertically oriented cylinders have a small diameter that doesn't deviate and stays relatively consistent throughout the entire build, as you can see. On the other hand, with domes, the base starts off with a big diameter and it ends in a minor point. Because of this, MARSHA doesn't demand for complicated 3D printers with wide-ranging mobility, making a habitat on Mars even more feasible and inexpensive. Now, surviving on Mars isn't just about structure. It's about weathering extreme temperatures, but MARSHA's got that covered too. Since Mars' surface temperature ranges from negative 140 to 30 degrees Celsius, if a habitat cannot expand and contract, it will fail due to thermal expansion. To accommodate for this, MARSHA's shell and base have been rendered as one structure, known as a flanged shell. The flanged shell smoothly glides on sliding bearings when touching the ground, ensuring controlled movement during the habitat's expansion and contraction. Simultaneously, clamps and soil anchors provide secure reinforcement against uplift forces, basically meaning that the habitat can stay on the ground without being lifted off. Nevertheless, habitats expanding and contracting creates numerous challenges for interior design. To solve for this part of the equation, AI Space Factory introduced a dual shell system to maintain stability, separating the actual livable part of the habitat from the outer pressure vessel. It's like having a weatherproof jacket over an entire house. Amazingly enough, this dual-shelled system offers more than just stability. The internal shell becomes a canvas for optimization. It is light, airy, and focused on human performance. A true architectural marvel, all with a purpose. A purpose to make living on Mars as similar as possible to living here on Earth. For instance, the water-filled window on top of the habitat utilizes diffusion to beautifully scatter light in all directions, creating an Earth-like environment. As if that wasn't enough, having vertical floors instead of horizontal rooms can make our Martian crew 13% more productive, according to Oxford University. Since a Martian would have to go up and down floors instead of across doors, there are more chances for unplanned events and social interactions. This is good news because dopamine, the happy hormone, gets released because of happy surprises, thereby increasing productivity. Suffice it to say that MARSHA's shape is incredible, and you best believe that MARSHA's layout has the same critical attention to detail. The ground floor is focused on extravehicular activities and a wet lab for scientific endeavors, successfully combining safety and functionality. The first floor includes a kitchen, office space, and a dry lab, making it a hub for collaboration and culinary delights. The second floor has a garden, a sanitation pod, and sleeping pods, offering sustainability and personal comfort. And lastly, the third floor features a communal recreation area, exercise facilities, and a water-filled skylight, highlighting mental and physical well-being, all under a natural Martian spotlight. Well, this is great. We have a fantastic design that is completely optimized for Martian living. Now, all we have to focus on is how we'll print MARSHA into reality. For those unfamiliar with the process, 3D printing works by releasing layers of liquid materials from a nozzle, eventually fusing and drying to create the finished, pre-programmed product. One of the most significant components of 3D printing is ensuring that the computer-aided design, or CAD, is as perfect and polished as possible. This is because the 3D printer will print out the programmed shape based on the CAD, even if catastrophic errors exist. To understand the process and get my hands dirty, I created my very own CAD of MARSHA using Tinkercad. A mix of measurements, creativity, and countless hours of hard work and scanning gave birth to the designs you see right here. One that could be sent to a 3D printer on Mars to officially make the very first Martian habitat. As we conclude this exploration into Martia's design, it's important to remember that it's not just about a habitat, but about finally becoming a multi-planetary species. We are part of a very, very unique generation because we can finally see the possibility of stepping onto another planet in the very near future. If you want to learn more about this topic, be sure to check out my in-depth article down in the description below that dives into the juicy physics behind MARSHA's design. And while you're at it, leave any questions in the comments section. Lastly, if you enjoyed this video and want to learn more about how we're finally going to get to the red planet, be sure to subscribe, leave a like, and share this video out to friends and family. Thank you so much for watching this video to the end, and I'll see you guys in the next one. Bye!